Hello. Can you hear me? Can you hear me? Good, good. Hello, hello, hello. I think we're going to see something probably not as exciting as we want it to be. I need some epic music. It's probably a it's probably a cover up. Yeah. Just waiting now. It's any moment. Gonna see gonna get some music. This better be worth it. Here it is. And we're going now with NASA's secret photos. Is everyone ready? Are we excited? Welcome to the podcast. If you're new, great, I am too. My channel is small, but I would love to grow with you guys. Join me. Grab yourself a drink. Get yourself a drink and get ready, because who knows what they're about to show us. The universe is filled with many mysteries out there. Are you guys ready to explore the stars? Let's see what they have for us.
Good afternoon and welcome to NASA's Goddard Space Flight Center. We are live today with NASA experts who are excited to share the latest images we have today of the
Oops, sorry, I got an echo.
3I means third interstellar, and ATLAS refers to the NASA-funded 3I means third interstellar, and ATLAS refers to the NASA-funded ATLAS survey telescope, which made the discovery. We are joined today by Amit Shathria, NASA's Associate Administrator, Nikki Fox, Associate Administrator for NASA's Science.
I got it. There we go. Sorry for that echo.
In the Planetary Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started,
hello Norma, hello.
Comet and share some images.
You just made tea? Me too, actually. I'm drinking some chai tea.
As Courtney noted, a NASA-funded telescope, the ATLAS survey telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I-ATLAS ever since. We're here today to give you the latest of what we know about Comet 3I-ATLAS and what we still want to know. But first, what is a comet?
What they still want to know.
A small, natural solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet.
Is it really?
It behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There's a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains.
What are they trying to say?
How magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share it with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things.
Here they go.
Something that's really important for
They're trying to tell us about the life on Mars now,
It could be an amazing discovery.
They're so scared sounding about something.
But 3I-ATLAS is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail. But just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter.
What is that?
October 2nd, as the comet sailed by.
Are you kidding me?
19 million miles from the instrument. You can see that Comet 3I-ATLAS looks like a fuzzy white ball.
Yeah.
That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun.
Guys, are you
I'll use
believing
my
this?
esteemed colleagues to share further details.
That's
I'd like
what we
to
waited
introduce
for.
you to the head of NASA Science, Nikki Fox.
Thank you so much.
Somebody
It is
blurred
such a
that out
rare
on Photoshop.
opportunity, for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery.
I don't
Just
believe
like
it.
Amit said, comets are tiny cosmic snowballs, and by studying them, we can learn about the environment from
They're not
basically when they
snowballs.
formed,
What?
where they came
What
from.
is-
This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar
Yeah, like
system.
17 anomalies.
3I-ATLAS, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning
That's
to be
right,
able
Sky.
to find them thanks to the
I know the
new
gaslighting,
technologies
Norma. I
with
feel
our
it. I
network of
feel it too.
Earth-based telescopes, which are designed to find
It's
small,
so
fast-moving
obvious.
objects in space. The NASA-funded ATLAS survey telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries.
Look at how they have to,
Just
like,
this one.
they have to speak, you know, and tell us,
NASA's Planetary
like,
Defense
kind of
Coordinating
prepare us
Office
for all this
established-
nonsense.
They studied it and they established
Almost like they're trying to,
that
like,
ATLAS is not a danger to Earth.
defend their case, you
In
know.
fact, it's at least
They're trying
twice
too hard.
Twice as far away as the distance between the Earth and our sun. On October 30th, the comet itself reached the closest it will ever be to the sun when it crossed just inside Mars's orbit, which is why the image that Amit just showed, he noted it was the closest instrument physically to the comet because the comet was right inside the orbit.
And
of
then they
Mars.
have to tell us too about the
Earth was
alien
on the
stuff that they
opposite
found
side
on
of the
Mars, you
sun,
know, because,
which is
oh,
about
they're so
as far away
transparent,
as
even
our
though they've
planet
had that
could possibly
information for
be
over a
from
year.
Mars.
But here they are now
It's
sharing.
really clear from the
They're like, but
moment
we've
of
been
discovery
transparent
that
with
the
you, so you
comet
have
was
to
going
believe
to
us
pass
on
the opposite
on
side
the
of
comet,
sun
right?
from where the Earth is. However, it was also clear that its positioning behind
Yeah,
the
that
sun was
image
going to
was
make observations
so
of Earth very, very
anticlimactic. We've
difficult.
had better
And
images.
that is why we are so happy to
So-
have our incredible fleet
This
of
is
NASA
so-
science spacecraft
this is
all
BS.
across the solar system, and boy, were they ready for this event. NASA
Were
science
they?
assets on board our missions have provided the United States the unique capability to observe 3I-ATLAS almost the entire time it passes through our celestial
It was a whole
neighborhood.
3 seconds of that horrible
Everything
photo.
NASA science does is interconnected, and nearly 20 mission teams have been working together.
They said they had a
to this
fleet
challenge. 20 mission teams,
of
by
these
the way, and
orbiters.
counting.
And you mean to tell me only that
Everything
one
we're
fuzzy
learning
photo
about
came
the
out?
comet is
That
possible
is
because
just...
of the distribution of all of the different instruments.
We
of our
waited
spacecraft
literally
with
weeks for
different
this.
capabilities. And I'll note that for some
A
of them,
fleet.
we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I-ATLAS for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I-ATLAS include Hubble, the James Webb Space Telescope, TESS,
Yeah, I feel like...
SPHEREX, Perseverance Mars rover.
Exactly,
Mars
Sky. I'm
Reconnaissance
sitting here
Orbiter,
like...
Maven, Europa Clipper, Lucy.
They must have
Psyche,
something else.
Personal favorite, Parker Solar Probe, Punch, Stereo, and ESA.
They have to have more than that one
mission.
photo.
And I'll note that Parker Solar Probe's data were just downloaded
I don't believe
yesterday,
it.
and indeed, we did catch several glimpses of this amazing comet. The scientific
Several
community is
glimpses,
hard
so
at work
they might have more.
analyzing
They're
these
just
images,
making us
and
wait.
everyone,
We have to
as
sit through the
always,
nonsense.
is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7.
That is
And
a
we
lie.
in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask. And this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study.
Norma, I know. I've noticed it's all like so obvious, like manipulation, you know. It's like this weird, I have to point this out, you know, so that this can be seen as some kind of trust thing. It's almost like we're listening to a bunch of narcissists.
With the world, including the science community.
Yeah, Leslie, there was one pic. It was extremely fuzzy and just a ball of nothing. And they're acting like it's just a ball of fuzz. Like it's not that important. It's so funny.
Together to take advantage of this rare opportunity.
They say they have more, though.
Came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT.
Oh my God, they act like they're trying to sell us an orbiter. Like, I'm not here to buy the orbiter. I'm here to see the photos, show the photos.
Even our other great telescopes can't do. So every time we add to the fleet, we add
the fleet
additional capabilities that expand the realm of the possible.
Did you hear that? The fleet. Why do they keep using that?
Early on, determine what its structure is and what its composition is.
Are they trying to tell us something?
It's a beautiful illustration of why we have not just one space.
The true UAP bus.
Every one member of that fleet specializes in a different kind of information.
Do they really call it a fleet?
A different piece of the puzzle to the total understanding we have from the fleet as a whole. So, for example,
oh my God, yes. From now on, when we have that, I'm gonna be like,
earlier this year. Not too long
it's the fleet.
It looked at 3I-ATLAS not long after we discovered.
Why is this image better than the ones that they call the high-rise images?
277 million miles from Earth.
This is an old one that they took, like from, I don't know, millions of light years away.
Coming off that solid, icy nucleus.
And yet the ones that they took, which were right next to Mars,
astronomers were able to
are fuzzy.
narrow a few things.
They're lying.
Importantly, the size of the nucleus.
These are lies.
We know it's between, at that point, actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter.
Norma, they're selling it to us, man. They're trying to make us truly believe, you know, that this is just a comet. It's nothing to see here. Just look at the fuzzball. Look at the fuzzy ball.
Orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope.
Yes, we know.
We added this to our fleet.
They're like telling us what we already know. Yeah, like we know. We've been waiting weeks for this. Like, let's go.
Which we only launched at the beginning of this year.
They have to fully explain themselves because they're trying so hard to defend themselves.
Infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And
what?
infrared light is particularly good at helping us understand the composition of objects. We can
fuzzy blue balls.
Molecular fingerprints from the things.
Leslie, don't go there.
So with these infrared observations, with James Webb,
you crack me up, Leslie.
Abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust.
Look at how are these images better looking than the one that they took in the high-rise images?
Those are the little like science wiggles you might see in the top right of these images.
Like this is even better. Even that pixelated one on the end.
Those fingerprints of those molecules that the comet has a nucleus.
A fuzzy fleet of blue balls.
As well as the presence of water ice. Now,
Leslie,
ratio, like we can
behave yourself, Leslie.
Things are there. We can also say, what's the ratio of carbon dioxide to water? And we now know that. We know it's larger than what we usually see in solar system objects.
So they're saying it's
There's a lot
larger.
of
That's
natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away.
they really have to
But
explain this
there's
to us,
other
don't they?
well-understood processes that could also explain it. I'll just to put this in context.
We want to see the
Our-
proof, though.
Every time we look beyond our solar
NASA,
system
show us the
and we
proof.
look
Like,
at
show us.
the ratios of carbon dioxide to water, we see whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could
Guy
be,
I know.
this is the last theory why those ratios could be different, that these ices could have been exposed to higher levels of radiation.
I know you
on
can't help
themselves.
yourself. I know, Leslie.
Or, as I said before, could be that the comet just formed from a
Norma's
a region where
laughing.
Carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information
They're just telling us what we already know.
before it got closer, and when the
We
sun
waited
was
weeks for
was
this,
pointed at
and
it.
this is their
Now
this
that
is their
the comet
pitch.
near, our, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
Let's turn it over. Let's do that. Yes.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw
In this
the
play,
animation,
so they're already admitting that they're acting.
The sun, of course, is at the center of our solar system. The planets are orbiting around the sun. And in this case, Comet 3I-ATLAS has come through on
They
its
claim they
orbit
have a
in
fleet.
the opposite direction. And,
They keep using the word
it
fleet.
arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is
The
really
fleet is
excited about
hilarious
the
to me,
comet
too.
and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific
Oh,
opportunity.
Leslie.
It's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions.
I'm wondering if
to
we
ask
should have
about
brought alcohol instead of tea, ladies and
now,
gentlemen.
let me start by going directly to what we were able to
We should be
see
taking
at the
shots for every
beginning
time that they say the word fleet.
Of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet. That had
Don't get
great
fired, Leslie.
opportunities for potentially observing 3I-ATLAS, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into.
Norma's about to pull the wine.
Now, let's
I'm telling you,
September,
we really all
and I
should have
can
been
show you
drinking for
a
this
sampling of
because
the images
were we
collected by our
expecting to
different
actually see something really
so the
detailed, though, you
context,
know?
We're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big.
This is what they wanted to show us. Nothing but fuzzy blobs. Fuzzy balls. Why didn't he say fuzzy balls?
It's a little bit as if our NASA
They need to be
spacecraft were at a
honest here.
baseball game,
They're going to be
watching the
transparent.
game
It's
from
called a
different
fuzzy
places in
ball.
the stadium. Everybody's got a camera, and they're trying to get a picture of the ball.
There it is.
Nobody has a perfect view.
He
and
said
everybody
it.
has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's
Yes,
Psyche
show
mission
it.
acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that
What are they
you're not
showing
seeing
us? Where
very
is the
much,
images?
just wait a minute
Was
and
that
you'll
it?
see more. Now, the
That
following
tiny
week in
dot? That's-
September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that share Jupiter's orbit around the sun, called the Trojan asteroid.
NASA's out here getting clicks and likes. They're trying to build up their YouTube page. They're keeping us in suspense over here because they're showing us nothing.
Caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I-ATLAS, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale,
Trinks shot.
about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much
I take a sip of tea every time they say the word fleet.
Now, this
doesn't do anything, though.
From the Psyche image, part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to
They're trying to put us to sleep. I swear.
Dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit.
They have to really explain this to us, you
From
know.
the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand
By combining the
the
data,
dimensional structure of the comet.
we know
and
it's a
the nature
fuzzy
of the
ball.
dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture.
They are trying to make this as boring as possible.
At Mars.
What is that?
At the beginning of October, 3I-ATLAS passed within 20
What is
million
this?
miles of Mars, which
That looks
gave
like a
Mars
spaceship.
spacecraft an opportunity
You
for a
guys
close-up.
see?
And earlier, you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014.
They're trying to confuse us.
Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the
spectrum.
science wiggles that Sean was just talking about.
Why are they
These
doing
the
this to
science
us?
wiggles.
This
We
is
have
almost
the instrument,
torture.
The spectrograph, the ultraviolet spectrograph on MAVEN.
Norma's
and
little
look at the comet
emoji.
and also split up the ultraviolet light according to color.
Guys.
So you're seeing 3 different bands in this image.
Can we
On the
believe
right,
this?
You're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter
This looks like a
band,
portal. I don't know.
it's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I-ATLAS. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars.
We're supposed to believe that's
Space
Mars's
is in the
hydrogen.
field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image.
That looks
But
like a
it's also
portal.
telling us it's one of the many ways
That
we
3I-ATLAS
can
just
see
shot out of.
the chemical composition of 3I-ATLAS. And in this particular example, it's showing us the hydrogen gas.
So they're still not showing us any more
Now,
detailed
these
images. I
observations,
mean,
combined with
they had
the
all this
observations
fleet
by
of
Swift
orbiters
and Webb that Sean
that could
spoke
take
about,
pictures of it
that
really up
water
close.
production rate, how much
I mean,
water
closer than
is
we
released
are
from the
to
comet,
3I-ATLAS.
when the comet is warmed by the sun, which provides insight
And these
into
are
the nature of the
high-rise
comet
images.
and its journey
They're very
to our
detailed
galaxy.
images.
Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I-ATLAS from October 15th to 16th.
Oh my God.
after
Now they're
it
showing
left
us
Mars.
this.
And SOHO spotted
Another
the
fuzzy
comet
ball.
crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the sun. Comet 3I-ATLAS was expected to be
222
for some
million.
to see, but this result was made using detailed image processing.
That was a
and
synchronicity
overall,
number.
or we call it
Just
stacking,
pointing that out for everyone.
subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case,
I know, I think
from the telescope's point
I
of
think
view.
NASA's just trying to blind
You'll be
us
able
with
to see
these.
the rest of the images on our 3I-ATLAS website, go.nasa.gov/3I-ATLAS. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with.
Oh, they have to tell us
Doing the
this.
analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of
They make it sound like it's really, really like, you know.
published in peer-reviewed
Wait.
scientific journals. But the answers will come later on.
So,
We're still at this phase.
are you
very
kidding
much in
me?
the state where we're figuring out what are even the right questions to ask about interstellar.
So they really don't know what this
is
thing
a
is.
snapshot of where we are very
They're
early.
over here trying to feed us a bunch of nonsense, but
Back to you, Courtney.
they are even trying to tell us, oh, well, we're still analyzing it. Like, so where's the real science here? Like,
*1 to enter the queue and ask your questions.
oh, we're going to get to call in? Should I do it?
From Marcia Dunn with the Associated Press.
I'll just call in. Hi, is it a ship?
Hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question.
Norma, I totally agree. It looks different every time.
The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations.
Should I just
that,
call
Sean
and
was
troll
talking
them?
about. So we're still right now in that range of somewhere.
Pretend to be like an
sort of,
alien from 3I-ATLAS.
Couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations.
So
It's obscured
they're claiming
by
they
the
don't know
dust,
the
and
shape.
Especially it's obscured by the reflected sunlight off of the dust.
They have
in the
high-res
coma.
images. They're
But
not
what,
showing us.
Observers from the ground have been able to do is observe the
This is
brightness
just
of the center of
nonsense.
the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still.
Look at how he's stuttering. He can't even tell you if it's an elongated object without stutter. He doesn't.
It would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back.
Look at that body
to where
language.
it came from. But things are not quite so simple. Our galaxy
Not so simple, huh?
is a big and complicated place.
It is indeed
And,
complicated.
the sun and all the other stars in our galaxy are in orbit around the center of the
So this thing isn't just a fuzzy ball, huh?
So 3I-ATLAS has been in interstellar space for a very long time. There is
Guys, they know
substantial
something.
evidence, given how fast it has come in to our solar system, that it came from some very old population, some solar system around a
Population.
very
Did you hear that?
quite
Some very
possibly,
old
this is what
population.
the likelihood is it came from a solar system older than our own solar system itself, which gives me
That was a slip of the tongue there. An old population of what?
It's not just a window into another solar system. It's a window into the deep past, and so deep in the past that it predates even the formation of our Earth and our Sun.
All right, we'll take our next question from the phone bridge from Bill Harwood.
I'm waiting for someone to call and say, is it a ship? All right, Leslie, take care. Don't get fired at work.
Bill, if
Come
you
back to
can't
us.
hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. I mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously that you take seriously the proposition from some that this could be an alien spacecraft.
Oh my God.
I'm asking the question anyway.
He asked.
Number two, is there any evidence you
Look
see
at everyone's
in the data
faces.
you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system?
This man
I'll take that
is the
one.
MVP right now.
We love all of the different science and all of the different kind of hypotheses into what these things can be. You know, when you start seeing something, you just got to point. You know, it's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, you know, I was interested. I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool.
What is this rant of words? Answer the question.
We were very quickly able to look for sort of, you know, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, you know, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else, and that's why we're so.
Look at this run-on of sentences.
That we've been able to identify and track.
They're trying to save their butt. They can't say it's not a ship.
Predicted these things occur, and now, of course, we know better how to look for them, and we now have this amazing ATLAS array. You know, we're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yes, it definitely behaves like a comet. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as we and you know, it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool.
That's right, Sky. That's what they're doing.
Even our own star. Yep, it's going to look different because it didn't come from.
It's going to look different. You see how they're like, it's like they're trying to not say it's not that, but they can't really say it is that. Then they're like contradicting themselves, you know, oh, it's definitely a comet. And then they're like, well,
we expect them to be different from our own homegrown.
They're bullshit.
And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran?
Here comes the analogies.
Say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really
They're really trying to convince us.
I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not. But it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide.
This man stutters a lot.
It evaporates water. But it's evaporating more carbon dioxide compared to water. So that's a very interesting thing.
Yeah,
Comets,
it's an anomaly.
Evaporate dust, and the dust is broken down. The minerals
A spaceship would do that.
Ultraviolet light of the sun, and comets. We know comets put out nickel. They put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting.
Which is a sign of
really
technology.
And something to be studied in the future. So we're always interested in new ideas. We're always interested in
a new idea.
And all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
All right, we'll take our
They don't even. They're claiming they don't have real evidence of anything. Really, it's just all speculation. Based on what they know about comets and asteroids, but
Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet? What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data? And are you excited about anything in particular when it comes to better understanding how things are?
Anyway, I really appreciate that other guy that called in and asked if it was a spaceship.
Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the
Our UFO community is pretty amazing sometimes. We're going to just ask those questions.
And that is a huge question. And we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information.
They're really not going to show us all the images, are they?
Observation, and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects.
NASA's shadow banning you, Norma. You were speaking too much truth. They don't like that. I can see your comment now. But if you sent a comment earlier, the last one I saw was, I'm kind of noticing how all the images look very different. That was the last one I saw from you.
So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions...
NASA is trying to stop anyone right now from saying too much.
It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets.
They really let this man talk a little too much.
Really interesting, and we would have said, well, maybe our galaxy...
They try too hard.
Every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just, a whole system full of these small bodies. And so now what this will let us do is tell...
What are they even talking about right now?
Between the detailed and large library of data we have on those origins of our own solar system, and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems, of the dust spread throughout those other solar systems, and now with this visitor that got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
Small picture.
I love the sort of thought of it.
They got the big pictures, and they're not showing us.
We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up.
What if it's a frozen piece of technology that it's been traveling the universe for a long time?
Frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to...
Yeah, they're privileged, all right. They've been seeing the real stuff, and we're over here looking at fuzzy balls.
Coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you...
She hesitated a little.
Please, go online, take a look at go.nasa.gov/3I-ATLAS and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
And we have another question.
Said without actual, confidence.
What makes Comet 3I
Everything's going to be
so
just
different
fine.
compared to the other interstellar comets?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I, Oumuamua, that behaved very much like an asteroid.
An asteroid. That thing was a ship.
3I-ATLAS, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very
They just put names on things and claim whatever they want, right?
Inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around.
No, it wasn't. That's such a lie.
Really, really comprehensive,
There was no
observations
evaporation of anything.
Exactly what
It had no outgassing.
It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second,
The stuttering.
2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3I-ATLAS. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing.
His body language is just,
is in a lot of ways
he's crossing his legs to try to appear like he's not nervous and to seem more confident in what he's saying.
All right, Svetlana on LinkedIn asks,
It's also a guarding body language. I'm analyzing their body language.
Absolutely. Every piece
There he goes. The other dude's crossing his legs
we
too.
are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also
She
to make
keeps
sure
playing with
people
her
see the
rings.
tools and things
Do you
to
notice that?
analyze the data as well, and we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
She's trying to make the rest of us feel very included.
Includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects.
They're trying so hard to seem like they're very transparent. They wouldn't lie to us at all. It's so obvious.
Big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation.
Yes, please do explain the multiple jets.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual, so that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Did it?
Perihelion.
Jets. Yeah. The jets, right.
Yes, the jets. Remember that?
Activity, see more activity in the inner coma around the nucleus, right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases.
I'm sorry, guys, but the sun should have totally wiped this thing out if it was a typical comet.
Those jets to change over time. And looking at the details of
it was shooting so much radiation at it.
Is also going to be interesting, especially for that sort of like, what was this stuff? What was the area in this? What was this stuff made of in the area it was made like long time ago?
Our next question is from David Chandler with Sky and Telescope.
They are being very weird. You can see in the body language. They're trying to hide something with their legs all crossed, and that's to also kind of,
observations,
wait, let's hear what this guy says.
Showing you anything about any non-gravitational accelerations at
Ooh.
this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations?
Look at how they already know what to say. They have to look at each other like, yeah, okay. Yeah, you guys know what to say to this, yeah.
To answer some of that about the non-gravitational accelerations, this is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other.
Acts like a little rocket engine.
Common to see comets
do they hear
so
themselves?
changes in their orbits as a result of these little rocket forces, just called
little
non-gravitational
rockets.
accelerations.
Why are
This
we?
is being monitored very closely. I spoke to our orbit determination team at the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going.
Why do I feel like it's a lie that they don't know what the nucleus looks like?
Have been very much on par with the sort
Do you
of
guys feel that?
in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had
This
an
thing was so
opportunity to
close to
like
Mars.
this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional.
They're not going to show us. We're going to have to turn to amateur
There's probably a lot more that
people, that amateur astronomers, to see this.
Data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning.
Yeah, for 2 seconds, and it's a fuzzy ball.
At that image.
So that's really all
I
it.
think, Sean is not bragging a lot on what these
This is it.
telescope. I don't know why, but
Guys, I don't
we're able to
believe
look
it.
at in infrared with the James Webb Space Telescope.
No,
that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope.
They're hiding everything from us.
Longer than anyone else.
There's no way. There's no way that's the image they.
Deep, rather than sort of across and wide, and the fact that it looks in the ultraviolet, so in the infrared, so it can kind of see the dark objects, and so I'm really excited about just sort of tracking it to the very end. Also noted we're downlinking
What
data
dark
from,
objects?
Missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us.
They're so light. How do they not have this? And they're like, hey, we're going to do a live and show you all this great stuff.
Sharpening up those images and really,
and they're like, oh, I haven't seen it yet. Have no idea what it is. They're such liars.
So everyone can see them, but we'll take some time and do some, real sort of deep looking.
Come on, guys.
Do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars.
I think she's shaking.
Take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that.
I don't know.
As we move
I'm not buying it.
Things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
You want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for
excuses
doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that.
Okay.
As Nikki said, our desire was to get these images out to the public as quickly as possible, and so there are some image artifacts in there that you'll see, and I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. The little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the SOHO image where we actually stacked a couple of images because a single image you wouldn't be able to see it would be too faint, but if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next.
Yeah, well, they better get to work. Our tax dollars aren't paying them to sit around and just show us a bunch of fuzzy balls.
Orbital dynamics and space is really, really huge, and so it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now one light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting.
I know, Sky, right? It's been nothing but just rambling on and trying to pitch to us that they're not liars and they're showing us everything. They're so honest. They're so telling us the truth. There's no reason to hold anything back. They obviously haven't seen any of the real data
Not unusual because it's not gravitationally bound to our sun, but it's slightly
And they're giving
different.
us the obvious explanations, like we're here for the high-rise images, like, and they showed us the most low-res images.
Where the sun and the Earth are 1 foot apart. That's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see. It's so small. The entire solar system will just barely fit in your house if you squeeze a little bit. And the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question.
They talk to
is
us like we're all
Inspector
stupid
with
guys.
Live Science.
It's unbelievable.
I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
Yeah.
I'm going to pass it
Good
to
question.
Sean to talk about ages in the galaxy.
Okay.
So, so cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I-ATLAS is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood, which is telling us that it's coming from a different population from what we have generally around us.
There's that word again, the population.
The age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain.
I love how this just keeps going, and it's just almost like
that makes us think
stuff to kind of confuse you.
Came from a solar system that had larger motions relative to our solar neighborhood.
They don't even know.
Older, but
They're just giving us a bunch of BS. This is just nonsense. Like, there's no evidence of this.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like, if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed.
Does this make any sense?
How well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood.
Well, then they better get to work. I mean, we're paying them to know about this, and they're like, well, you know, we just don't know anything about what's next door. But we can tell you what's existing in another timeline millions and millions of light years away from, like, the beginning of the solar system and of the universe.
Right, and so the
like what?
This is, like, the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I-ATLAS is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, this can't be true. These galaxies, but because 3I-ATLAS was closer to them than they were to JW, they got really good images of the object as it passed.
Okay, well, where is it?
As you said, we can image individual grains on Mars because we have space.
1 minute they're telling us they can't get the good images, and then they're saying, oh, you know.
To 3I-ATLAS, we're still 19 million miles away.
And it's
okay.
Too fast for us to send something there to, like, you know, intercept and get that close.
Oh yeah, here's the excuses of why they just can't.
We just don't have if we could, We would, like, we would be there.
They're laughing. We totally don't have that yet.
All right, well, that's all the time
They're
we
such
have for today.
liars.
Thank you so
We
much
have
for
poopy
joining us.
telescopes on
Be
Earth
sure
that can
to
see
follow
this
along
stuff
with
better.
NASA as we continue to observe 3I-ATLAS. Find new
Like our
images,
regular
detailed
telescopes.
information, and
Like if you watch
resources by visiting
Tiago,
go.nasa.gov/3i-atlas and by following NASA Solar System on social media. Thanks for joining.
like if you guys watch Tiago, he does it with his own telescope, and he's showing us blobs, float a blob of 3I-ATLAS. That was just, I don't know. That was the most anticlimactic, I don't know. That was just a pitch of, well, them claiming that they don't know if it's a ship. They don't. Oh, sorry. Yeah, I can't say that I think they're telling us the truth. I think I honestly don't believe it's the truth. What is this? We don't want this. Stevie Nicks playing. But yeah, we really just, I feel like they were just trying to pitch to us a bunch of lies, and I don't know. The reasons to why they can't do it. But then they gave us this one image. Come on. One image? You mean we've been waiting all that time? This was the big hype for something that looks worse than what we took when we took a photo of it, when it was outside of our solar system. Like, come on. This is just, I'm not believing it. I'm not buying it. I honestly don't believe it. I actually think it's, I just think it's not true. I do. Their body language, if you guys noticed, seemed a little off. It really did. It was very guarding a little, And then the lady was playing with her jewelry on her hands, using her hands a lot, kind of trying to be like very confident and sometimes even sophisticated, like putting her fingers together like she knows exactly what she's talking about. But then there was moments where she seemed a little hesitant, and she starts like playing with her rings on her fingers, and just a lot of fidgeting. And then you have the gentleman that constantly talked, and he had his legs crossed, and he seemed to keep like stuttering a few times. You could see him looking off. His body language just, I don't know, seemed a little like he was struggling to try to tell you it's like the color is orange when it's really purple or something, like, and then give reasons to why it's actually orange and not purple, So it's like we're all crazy if we're seeing this, but that's what I think. It's my opinion on that. I really feel like this wasn't the most honest thing that they've done. I've followed NASA for a very long time, for over 20 years, just watching their stuff, and they did Photoshop stuff out at some points. You used to see images go up and then they would take them down, things like a lot of secrecy, and it's hard to believe NASA sometimes now. It really is. So, but anyway, we have everyone sitting here and telling us they actually don't have any images at all. They have nothing high res, just this one blurry image. And we're going to go to it, actually. Let's go to that image what they show us. It's like right at the beginning. There it is. Here it is. All right. So this is it. This is what they gave us. It looks like the moon taken at night on a cloudy evening. It's the worst image I think we've seen of 3I-ATLAS. And this is what we waited for. This is what we waited for. I don't know, guys. I don't know. But I am thinking that this is not honest. They know something. They know. Well, anyway, yeah, thank you for joining me on this podcast. It was fun having you all here, and I hope none of you actually did take a shot every time they said the word fleet, because you're probably passed out by now. But yeah, just know that this is, I think, not over. They were making it quite clear that they really don't kind of know. That they kept saying, oh, hey, hey, yeah, we have images, that we're stacking and stuff. We have to analyze the data. It's just, we can't just suddenly show it yet. We're not really sure, that they're just being very, to me, like, in a way, almost saving their butts by not saying straight up, it's not a ship or technology or something that they don't understand. They are saying, they really are claiming that this is, and when they asked, is this a, when the guy called in and asked, is this thing a ship? They give us a bunch of reasons to, like, why this might not be, and then why it's also kind of like, how the universe is just so big, we really don't know. So, I mean, it's just, it's like preparing us for something that they really just can't admit is possible, and also would put them out of business. Let's be honest. NASA would lose their job. If this existed, and let's just say these beings exist, like, to the whole world, everyone knows about it, well, what are we paying NASA for? And, like, if we already know, that's the thing about us experiencers, is that we know what really exists and that we know they're covering it up. We know that they know. We know that the government knows. We know that most governments on this planet know. And it's been kept a big secret. And probably not just by our own people. I think the beings themselves also try to be very secret. But they're very, very, like, stealthy. And they are the masters of illusion and stealth, and they don't want us to see everything, even these beings. And when they were with me, when I had my experiences, I noticed that, they are trying to be very discreet. They're trying to hide, they're trying to stay out of our sight, and they have abilities to basically cloak themselves, to make themselves invisible to our naked eye. And that, to me, is something that I just, they don't want us to see it, and they try their best to not traumatize you, but you're going to see it. You're going to be traumatized, right? So, and with NASA, they know. They just don't want to admit it because they want to be the ones to release it, or they want to continue milking money out of us because they like what they're doing, just studying rocks and ice. But the thing is that they know that they're getting to have the fun stuff, and they're just showing us rocks and ice. And then, of course, at the beginning of this whole stream, they had to tell us, oh, well, you know what? We're being so honest with you guys. Like, we're being so transparent. So, as you know, we released the info about the aliens, the bacteria on Mars. We found that. So, wow, that's it, right? Leslie, you're back. Welcome back. And you missed nothing. They showed us nothing. They answered some questions, and that was it. Just the one gentleman that asked about the ship. So that was it. He was taking it for the team, man. Like, he was all of us. All right, he was all of us. He made himself out there and asked. He held back nothing. So congratulations to that gentleman who spoke for all of us, basically, asking if it's a ship, straight up. And of course, they just gave us their nonsense, right? But here it is. Here's the image. This is it. That's all they gave us. A snowball. The moon under, like, fuzzy clouds. Like, I don't know. This image is terrible. This is not a high-rise image. This is a lie. Like, that thing was very close to Mars. 3I-ATLAS was extremely close enough for them to get a good shot of that. And now they're claiming, well, we have some other stuff. We're compiling it together. We have to do the thing where we layer it on top to get that nice crisp image. A nice crisp image. Why do I feel like the next one that they release is just another fuzzy ball? And they're like, as you can see, we have a fuzzy ball here. And you're like, that's not what we're paying you millions of dollars for. This is a gimmick, is what this is. This is, and then they stream it on YouTube to show us this. Oh, come on. Oh, come on. Anyone believing this? I don't know, guys. I come on. As an experiencer, I'm telling you, they're hiding everything. Like I know what exists, and if I know, I'm just a normal human being. Okay, I'm not part of NASA. I'm not secret military, and even I know that these beings exist in their craft. I've seen their craft. They've been around. It's not something new anyway. I mean, this might be some old technology floating around that is so old that it's, and then they kept using the words like population. It's from another population of people. Yeah, we know. Yeah, Leslie. I know, right? It doesn't surprise anybody really. But I mean, were we all expecting to see some really beautiful, detailed images of this? They can't show us that. Especially when the person that called in asking about the jets. I mean, this thing is spewing jets, like in the same direction all the time, too. Which, if it was a comet, that dust and stuff and gas coming out of it would be flipping and rotating as it rotates. And instead, it's just always in the same direction. That's a ship. That's a craft. That is some kind of technology. And it just feels like it powered up at the sun to me. That's what it did. It powered up, got what it needed, and it's on a trajectory somewhere else. And if you guys watch The Angry Astronaut, I'm not sure if you guys watch him, but he has a really good theory. He thinks it's going somewhere. It's on a path to this galaxy that exists outside of ours and nearby. And it basically had a bunch of dust around it. Like, I don't know, I'm not going to give you a number because I don't know that number, but it's a massive amount of dust around this massive galaxy. And this dust just disappeared in a very short amount of time. Like, we watched it, NASA watched it disappear. And there's no explanation for it. Well, guess where 3I-ATLAS is headed? Directly in the path towards that galaxy. Now, why is it going there? It's literally right on there. So I recommend, if you want to know more about that, look up The Angry Astronaut here on YouTube. And yeah, that his theory is amazing. And he has a video on it there, so you guys can watch it. It's brilliant. And I was like, oh, wow, that's very interesting. And it's a nearby galaxy too. So, and it's headed directly in. Now, what are the odds that it swings by our sun, picks up the energy it needs, and now it's going directly towards that? That's fascinating. So, I'm not really like, I'm not saying this is a comment at all. I still think this is NASA just making their own claims. There's no evidence truly that 100% convinces me that this is a comet. It's just a bunch of speculation. And to me, that's very strange. So it's very strange how they did this. It's very strange that they only gave us this one image. You know, they're over here trying to tell us it's definitely a comet, 100%, like, you know, but then at the same time, they contradicted themselves. When people ask them questions, you know, of this being anomalous, they're like, well, you know, we're still analyzing the data. And I'm just like, so you guys really don't know. The science is there, but then it's not. And that's the whole gimmick here. That's the whole pitch. They pitched to us, guys. They pitched. And I don't know. I'm not gonna, I just can't. I want to believe that nothing out there is just, I mean, I don't want to believe that. I know the truth, but I'm saying that I want to believe they're telling the truth. I want to believe NASA's being honest with us. I really love NASA. I mean, my grandmother, my mom's biological mother worked for NASA, and she told me, don't believe them. So, I mean, I believed them up until that point, and then when I finally got in touch with her, because my mom was adopted, and then I ended up finding her biological mother through Ancestry.com, and I was amazed, actually. And she told me, she even proved to me that she worked for NASA. She went to college at the Kennedy thing, and then she basically worked basically work there as for the Apollo missions, and told me not to trust them because they lie. So I'm gonna believe my grandma. But she passed away last year. So, but I would have her come on the show to talk about it if she was still alive, because she's seen some stuff as well, and she would have come on. She would have come on, especially if she was still fighting the cancer and all that. She would have come on here and said her piece, because she's got nothing to hide. So that's just the reality, is that sadly we're being lied to, and we're paying to be lied to, and we're given nothing but rocks and ice and nonsense and fuzzy images. And you've got to be kidding me. There are amateurs here on Earth taking images of this thing with their telescopes that look better than this. So I really can't believe that their advanced billion-dollar fleet of orbiters were unable to capture an incredibly detailed image of 3I-ATLAS when it was right there at Mars. Like, it was right there, knocking on the door, practically consuming Mars, by the way, with the gases and dust, supposedly, right? But they couldn't capture this. Oh, the coma was just so bright. Come on. Their orbiters were probably covered in this dust. Remember how big this thing was? When it was releasing, it's like, oh, it's about half the size of the sun. Wouldn't that consume Mars and its dust? No, yeah. Well, nothing on that, really. Nothing to see here, nothing to see. But that's it, guys. This is it. Look at it. That's it. I can't even zoom in to look at it. It's like really just a blob of nothing. There's nothing to zoom in on, no structure to it. They claim they can't tell what the structure is, what the nucleus is. How is that possible? Also traveling through our solar system. Exactly, Leslie. That's all it is. Just a ball of ice, nothing to look at. It's such a lie. It's such a lie. And they made up a bunch of lies about Oumuamua too. Like Oumuamua claiming, oh, well, it was giving off, a little bit of a gas. No, it wasn't. There is absolutely no evidence of that. Like, we analyzed that data and there was nothing there. So, and it even changed its trajectory. Come on. With no sign of outgassing. They think we're stupid. They really do. And they talk to us like we're babies, giving us the obvious, well, space is really big. Yeah, we know that. But that's why we pay you guys to do your job and tell us what's in it. Oh, they don't want to do that. Because like I said, if the aliens are out and about for everyone to see and everyone knows they exist, well, what is NASA needed for anymore? Like, we'll just ask the aliens, right? They don't want us to know. They don't want us to know. Half of them would lose their jobs. They love their cushy paychecks and their lovely little government job. And yeah, they don't want to admit it. And they also can't. I feel like they can't. They have to kind of keep it secret. Because if this thing was headed towards Earth, they would have no choice but to say, I think they were waiting for that. They were waiting, hey, if it changes its trajectory and it's on its way to Earth, we can't hide this from the people. But since it's just passing by now, they hesitated a little, though, when someone asked, is it just going to go on the same trajectory? And the woman fiddling with her rings says, oh, it's definitely going to be going on that same trajectory. And you can just hear this slight bit of like hesitation in her voice. Like she didn't know how to answer that yet. Oh, well, yeah. They are not sure. Let's be honest about that. They don't really know. This thing could just suddenly, turn itself around if it wanted. If it suddenly noticed, hey, what's that planet over there? It's blue. What is that? And then they were like, hey, let's turn this ship around. What would NASA say then? Oh, well, it was some intense outgassing. Technically, it's doing that right now, and it's still on this really strong path. A very intense path. So, it's on a mission for something else, and it's not Earth. I don't believe this thing is a comet. it has too much obvious stuff happening here that just seems a little technological. Okay, it might not be a ship, but what if it's something else? Some other type of technology releasing something, or a living being of some kind. I mean, it looks like sometimes we're looking under a microscope when we see these things. They almost appear, everything almost appears like you're looking under a microscope. So if there's bacteria and things and amoebas and cells and all that, when we look under a microscope and we see what that looks like, the universe is almost mimicking it. And the smaller things are mimicking the universe, right? So it's everything mimics whatever, just bacteria here, you know? It's very strange. And if it keeps going until it's really small, then why not until it's really big? And as you zoom out of the universe, it just blows your mind to even think this, but I don't know. I think there's multiple universes next to ours, and that might even explain the quantum mechanics behind everything. But getting out of that is just, our brains are going to melt. So we'll stick to 3I-ATLAS. But this is just really fascinating that they didn't show us anything really. They showed us nothing. They showed us some older photos, and that was it. But they didn't show us the truth, the real object here. They really didn't show it. And they know it. They know there's something. I mean, when he was asked about the shape of the nucleus, they were like, well, we don't really know if it's round or if it's, if it's flat. Like, what? Why'd they even mention the word flat? You know what I mean? Like, this thing is shooting out jets. It's doing all kinds of crazy things. It's tumbling. It's got some kind of, it's almost like it's got its own gravitational thing going on. It's got jets coming out while it's tumbling in the same direction. How is that even possible? That makes no sense. If it's tumbling, the gas and stuff would be tumbling with it. So none of this makes really too much sense. And they're not answering everything. They kept it very PG here. They kept it very simple. They took a few questions. And it seemed to sometimes that they all looked at this one guy when the really tough questions were there. Like, they were ready. They were ready for these questions. They knew what they were going to have to answer. The basic ones, about the outgassing or the non-gravitational pull of this thing, or push. And that's basically an anomaly of it, that it's just moving without any gravitational pushes. It's just doing its own thing. And yet, this is what they're doing. So, I don't know. I'm not buying it, though. I'm not buying this at all. I think it's just a bunch of word salad, and that's what we were fed today. So I hope you're all still hungry, because I'm pretty sure there's more to this, and hopefully we'll see what they serve us next. But it's definitely not going to be what we want it to be, and it's definitely not going to be, even if it was something technological, they're not showing it. They blurred this thing out. They blurred it out. They don't want us seeing. So they gave us the fuzziest picture they could find, and they were like, here you go, let's put it up. We're telling you the truth. This is it. This is the photo. Oh yeah, sure it is. Sure it is. Thanks a lot, NASA. We'll make sure to give you a bigger paycheck next year. All right. Well, anyways, thank you for joining me on this podcast, and I hope you all had a lot of fun watching it live with me. I had a good time. We were chatting, having fun. Hopefully next time we got to bring the booze. We got to bring the alcohol for this kind of a thing, because when they say certain words, we got to take shots. That's going to be the new rules of the future here for these types of things and events. So anyway, thank you again. And I'm so glad you all had fun. And if you have any questions or anything that you want to ask, I'm here. But other than that, yeah, this was a lot of fun, and I really can't wait to do this again with you guys. So at least NASA gave us some fun times for this, right? Like a fun way to hang out and have a good time, at least getting a chuckle out of it. And yeah, so have a nice evening, and I will talk to you all very soon. Thank you for joining me, and don't forget to keep looking up.